Hello out there in TV land. All right.
You didn't see where Phil was, you guys?
I am not Tony, and I am not teaching airbrushing 101. I am teaching Arduino 101. So, and what Arduino is it's a small electronic prototyping board. It's got a number of pins where you can tie into it. You can send digital and analog signals to them, so you can flash lights or fade lights. You can also control a variety of other devices, such as a stepper motor, a regular motor, and there's a variety of sensors. I think I have a tilt sensor in there. You can get temperature sensors, moisture sensors, just all kinds of things. But what I'm focusing on is how do I light models? So,
That's why I'm here.
and before I get too much further on it, you see how big this is. I could put that inside of a model, more likely putting it inside of a model base, but I can get a smaller Arduino that'll fit nicely inside of a model.
And most of them.
This one even has a loader that you connect to it. Actually, they're not.
I'm just being facetious.
Oh. I've got a lot of money sunk into this, but it's like, at any one time, I'm not spending more than $30 to buy something. So, well, right now, and I'm just going to talk about the basics of it. Right now, actually, let me do something here on the back end. This is actually something a little bit more difficult than what you would normally get, but it's doing something that does the same thing as one of these standard sketches. So as I said, if you have programmed computers at all in the last 20 years, you will recognize the programming language that Arduino uses. It is a variant of C, and C is a programming language that was made for hackers. So it's like you could do everything with just very few keystrokes. But it follows, just real easy stuff. So on this one, this is what's running on the Arduino right now. And this sketch is actually loaded in it by default. It's called Blink. And what it does is, I don't know how you can see it, but we go through the program and we want to explain how the program works. We've got comments up here at the front. Then we have a function called setup, which is anytime you hit the reset button or you plug it in the power. With that one, we are defining the mode of the built-in LED to be an output. So it's basically, we're talking to the LED, which is the built-in LED is what's flashing right there. Then we go into the loop, and this just runs over and over and over and over until you turn off power. And the way this one works is we start the loop, and then we're going to do a command called digital write, which is basically we're writing a signal to this pin, and we're saying that it's going to be high. And all that says with the digital write, it's either going to be high or low, on or off. Right? And that's something I learned the hard way the other day when I was playing with one of the analog pins, and it didn't want to do it that way. I said, no, I can't do that, so I got to do it differently. So it's basically, this is saying, we're going to start the loop, digital write, and we're going to set the built-in LED to high, and I've got a comment over here that says, I'm doing it. Then we're going to delay 1,000. The 1,000 in there is how many milliseconds we're waiting. So we're waiting 1,000 milliseconds, or 1 second. Then, once we're done with that delay, we're going to do another digital write, and we're going to set the pin to low. We're going to turn it off. And then we're going to wait another second. So that's all it's going to do. It's going to keep on running that loop. And one of the brilliant things about Arduino is I can start adding things to this. I can expand the sketch. I can add functions to it where it's like, okay, I'm going to do this, and I'm going to run over here and do this real quick, and come back. I'm going to run over there and do that real quick, and so we can do that. But if I'm using delays a lot, the delays build up, and they cause bad things to happen if you have too many of them. So I created a function where, come on, my mouse. That's the problem. This is why I wish the monitor was working. I'm going to show you what I did on the side. Come on. This is embarrassing. Come on, work. Okay. Of course, nothing works. The mouse doesn't work because I've got one working USB port on this laptop, and the mouse doesn't like the breakout box. So what I did yesterday was I took this blink function and I changed it because I know computer programming. And what I did on this one was, okay, so I'm gonna do the same thing, but I'm gonna set some things up. I'm gonna declare a constant, my interval. So don't change. So I set my constant interval equal 1,000. So I set it to 1,000 milliseconds. Then I declared some variables. Variables do change. I'm going to be changing the values as the program goes forward. And one thing I didn't do was, you can see how you can kind of read that in English. Make them readable in English so that when you come back to this in 6 months, you know what you did. That's why you put in the comments and you name your variables the right way. So I've got an unsigned long integer called current time. I can get into the technicalities of it, but unsigned longs, they're really big. They're like 65,000 characters. Big numbers, but I'm counting in milliseconds. So this number, if I let this run long enough, these are going to get really big. And then I've got another one called change time. So I want to keep track of what time is it now, and when did I last change the light. Okay? And if any of this doesn't make sense, ask questions, please. All right, so where's all right, so we're going to do our setup, and I explained that one before, that we're going to set the pin mode as an output, and then we're going to go in a loop. Sorry, so we start at the top of the loop. And the way I set my comments up, I'm saying what I'm doing at each step, because that helps me figure out what I'm doing. It's a comment. Ignore this. This is something for humans that, computers don't need to deal with. So, you can set up big comments or little comments, but 2 slashes, start a comment. And so I was going to say...
Can you tell it otherwise?
Well, it's basically, if I do two slashes like that, it's going to ignore everything until it gets to the end of the line character. If I do... The other way to do a comment with the long ones is it's a slash asterisk, and it'll treat everything past that as a comment until it gets to an asterisk slash. So that causes problems too if you don't. There's lots of things. Everything tends to get matched, and if you don't do the right thing to close off things like parentheses, brackets, they're all looking for its mate, and if it doesn't see the mate, then it causes problems. But usually they'll catch that before you launch your program. All right, so we're going to read the internal clock, and so I'm setting the current time to. I'm using the function to read the clock. Then I ask, have I waited long enough? Have I waited 1,000 milliseconds? Because the way this is going, it's just going loop, 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 loop. So, and how I'm figuring that, I'm saying if current time minus interval is greater than or equal to change time. And remember, change time was the last time we reset the light. So if that's the case, if we waited 1,000 milliseconds, I'm going to. I didn't tell you about my state. I made a variable to keep track of whether the LED is on or off. So that's important too, because you do it this way. Is it on? Is it off? If I just go willy nilly, I'm not going to be able to remember. So I've got to set something in here to remember what I'm looking at. So, all right. So if I waited long enough, I want to change the state. Then I say if state equals high, and the reason you may notice I put 2 equal signs there. Look up. Let me see if I can move this a little bit closer. This is small and it's not nearly contrasty enough. All right, so you can see the 2 equal signs there. That is so that I can make a comparison to other things. 2 equal signs say, is this equal? I could take 2 ampersands to say, if this is true and this is true, then we're going to do something else. I can ask if it's not equal, exclamation point and equal sign. I can ask if it's greater than, less than, greater than or equal to, less than or equal to. So this is all the comparisons. And like I said, if you've programmed in C, this is the way the C language works. But I'm going to say, okay, if the state equals high, then I'm going to set the state to low. Otherwise, I'm going to set it to high. So basically, it's like I don't need to ask whether it's low again because I already know that it is. So, and then it goes on out there, and then once I decide what to do, I'm going to go ahead and I'm going to update the.
Anybody who wants to help
time.
Judge, please meet up here by the doorway, and the more the merrier, the faster they go. Thanks.
And then I'm going to update the state, and I'm going to end the loop. And again, this is going to go round and round and round. Like I said, I can build this up to that I can do this, I can do this, I can pull in lots of other things and do things.
Do you have to have the computer there?
No! I'm glad you asked that. Okay.
What a segue.
It wasn't the planned segue, but I can do it.
$10.
All right, so you're absolutely right. What this is doing, the only time you ever really need to connect the Arduino to the computer is to push the code. But the way that it was pulling power off the USB cable. All right. And you can do that. So I'm going to take my handy dandy 9-volt battery and plug it in. Let's do the same thing. I'm going to do one other thing. Remember how I said that we're using the default LED? Well, one thing I didn't talk about is the default LED has a pin number on it. It's pin 13. So the Arduino can run about 5 LEDs without burning it up. And that's an important thing to remember because it doesn't pull a lot of current and you can overload it fast. Okay. So while I'm doing this, I'm just going to set this up to put an LED on here. And what I'm going to do is I'm going to that's 5 volts, I do that. I run ground to my negative bus on my breadboard. Run 5 volts, positive bus. Take out one of my handy dandy red LEDs. One of the things to remember on LEDs is they're polarized. And the way to remember which one is the positive and which one's the negative is you can see the pins. Always remember, well, the short one's negative. Short people have bad attitudes or negative attitudes. So the short pin, and I did that with an electronics project where I wired everything backwards. That was embarrassing.
You run them in a string and you can one stack.
Yeah. So I'm going to go ahead and I'm going to put this in here, and from the breadboard, each row is a different. All the on the edges of the breadboard, those rows are all connected. All those holes are connected. In the middle, these guys, each row is connected up to the middle. So this is one connection. That's one connection. So it's like if I need to put multiple things on it, I can. Another thing important to remember is LEDs do not like a whole lot of current. They need about 3 volts to run, but they can only take about 20 milliamps. So the way you can control that is you have to remember ohms law. And that's pretty easy to remember because you remember. So you in my notebook. This is also another thing. I have a notebook where I write down circuits. But on the very first on my notebook, I wrote down Ohm's law. And the mnemonic to remember on that is Earth is round. And if you want to figure out anything, you just cover up the variable. E is voltage, I is current, R is resistance. I want to figure out the voltage. It's current times resistance. I want to figure the current. I want to figure the current. It's the voltage divided by the resistance. So I've already done this for this, and I actually did. I smoke checked an LED last week too. I didn't do this. Basically, you want to put a resistor on it. And a good way of understanding electronics is think of a garden hose. You hook up your hose, you turn on the spigot, you get all the pressure coming through. If you put on a sprinkler, it's going to cut down how much water is flowing, and it's going to take away some of your pressure. The water pressure is your voltage. It's how hard the electricity is being pushed. The resistors are your sprinklers. They're restricting your flow. And the amount of water flowing through it is your current. So I'm going to use this resistor to limit my flow. I'm going to put it on the negative side. You can put it on the positive side too. I just do it because I like putting it on the negative side. That's another good thing to remember when you're working with electronics. Just do things the same way, and you won't make mistakes.
Learn it once.
That's right. Are you familiar with Ohm's law, sir?
I've heard of it.
Okay. So I'll show you that. So my little mnemonic, Earth is round. Figure out any value, voltage, current, resistance. If I want to figure out a value, just cover it up. Shows you the equation. This may work, this may not work. It's hard to see. That.
I don't like it so much when they work, it's when they don't work the next time.
Yeah.
I'm doing two enterprises. I'm doing Enterprise A and Enterprise D. And I'm trying to light the window.
This is the beginning of my Enterprise A circuit. Alright, so I hook up the negative lead to ground, and I'm going to hook up the positive to pin 13. And now, so basically, I've just basically said the built-in LED is going to flash, but since I know where it's hooked up, I can write to that pin as well. I can read that pin. So and if I were to go out forward with this sketch, this is bad programming because it's like you may get this sketch from me. I may say, yeah, this is really cool. Go ahead and use this. And you read it and you say, well, where's the built-in LED? It's flashing on the Arduino. That does me no good. So it's just know where your pins are. So now we're gonna do a different thing real quick. Any questions on that? I feel like I'm kind of like rambling.
Probably wouldn't help.
No,
Keep
go
on
ahead. Go ask questions. So, and what kind of lighting effects are you wanting to do, sir?
Well, actually, he was designing also like the recent enterprise, changing the reflector bridge from the gold color to a blue color. And back. Rather than just taking two LEDs and then doing just changing
Yeah.
it from one to the other.
And actually, that's one of the things that I did. I got RGB LEDs, and that's the one I smoke checked because I was trying to figure out which pin goes where, and I was hooking up the red element straight to 5 volts. It wasn't going through the resistor. It's like, wait a second, it's getting darker. It's getting darker. What's?
What's that smell?
Oh man! I let the magic blue smoke out of the LED. Letting the magic blue smoke that makes all electronics work out. If you let it out, that's bad. Where is my mouse? So, and as I was saying, this is the start of my enterprise, my refit enterprise circuit. I can explain that to all you real quick because this one, I got 2 RGB LEDs. They're going on over here, and then this one for the blue. This is controlling the warp circuit. And this is controlling the impulse circuit. So there's my impulse lights, and I've got some UV LED tape for the edges. So what is going to happen, and I'm running these off of some transistors. Like I said, you can't run too many LEDs off the Arduino without killing it. It'll draw too much current. So I'm sending the control signal to the transistor, and it's running very little current. But I'm going to run 2 amps through the rest of it to light these things. So everything's going to be running at 12 volts and 2 amps all circuits, and I'm just going to be using the transistors to keep from overloading the computer. 40 milliamps, 50 milliamps. It's not a whole lot of LEDs to overload. So, and if you get an Arduino like this, where with the plug-in chip, you can probably replace this chip. If it's one of the ones that's surface mounted, you're buying a new board. And I don't know if I I'm losing things already.
There's a tiny bag over here.
I'm looking for this one. Yeah, this is the one I'm going to end up putting in
Oh, wow.
my model. That's functionally identical to this. So I'm going to use this one to develop my circuits, and then once I lay them out, I'll push the code to that, and that gets embedded in the model.
Where's the power supply?
The power supply will come in onto pin number.
Okay, so you're going to run this off of this.
Yeah. Well,
Okay,
basically, what I'm
gotcha.
going to do is, if you look at this, you got a voltage in and a ground right there, and basically that voltage in is how if I'm not connected to anything else, if I was just running this off of a wall wart, that's where I'm going to send my power. And you can send between 5 and 12 volts. And since I want to run the whole model on a 12 volt system, we'll just tap in that's the 12 volt line.
So you buy this as your control. This just
Yeah, and basically when it comes time to program it, once I get my code done, I'll attach this to that, and this has got a mini USB, so I just write the code to it, I push the code from the computer there, and then it's burnt onto the chip.
You reprogram the chip to,
Yeah. As a matter of fact, I did that while I was talking about it because I pushed my milliamp example of doing the blink without the delay from my computer. And I'm going to do it again here. going to do this one. I'm going to show you. We're going to do a fade.
It'd be nice if we could do like a program fade from the gold color to the blue color and back.
You know what? You can. And I don't have the sketch on this computer. This is my wife's laptop. I don't have a laptop that I can do fun things on. It works. I'm going to open that one up. And I'm going to move this pin over to pin 9. I'll show you this one right here. Real quick. I'll show you this one. Take a look at pin 9. And you'll see a little squiggle right by it. Well, it's a tilde. And basically what that one's saying is I can do pulse. I can make that one fade through a programming technique called pulse width modulation. So it's basically I'm going to control the amount of time that the LED is on, and I can change that amount from 0 to 255. So I got 256 stops that I can use, and how on this is going to be. Let's hook it back up to the computer. Push it. That's the button for uploading the code. And you're gonna go. This is my wife's laptop. She doesn't even use it anymore. She would much rather use her Kindle because it's just faster. And I got a bunch of the stuff that I've got out in my various experimenter kits. Got some multi-segment LEDs, some single port not selected.
See, this is what frustrates me.
Button pushing.
Yeah, you know you've done it right, you think you've done it right, and it doesn't work, and you spend hours going, where did why did I wiggle? Sometimes it just drives me nuts. It's so frustrating.
Well, like I said, this laptop has seen better days, and it's only got one USB port that really is working. As we just saw, it's not even working that way. So if I do this demo again, I will make sure I have a different laptop. Alright, so now that it's gone, you'll notice
That's
the LED
exactly
is
what I'm
filled.
looking for my navigation lights. Just like that. Or something that, I'm sure you can do this too, where you get 2 quick blinks and wait, 2 quick
yeah.
blinks and wait.
Yeah, you can, because it's like just with the, like the way that I showed you on the first one, it would be like, we're going to do, you would set it up so you've got three intervals. Interval 1, we're going to wait real quick. Interval 2, we're going to, interval 1, we're on for a little bit, and we're going to wait a little bit. And we're on for a little bit, and we're going to wait a little bit. So you just basically say, I'm going to go through these 3 steps. And I loop it again. Go through these 3 steps. And I wish I had it. It's on my desktop. I had created a sketch where I'm trying to light an NX over, and I want the ends to be pulsating, not just flashing, not just spinning. But I want them to fade and pulse, because on the show that's what they did. And then setting up the navigation lights where they're on a second, off a second, and setting up the strobe lights where they're flashing twice a second. And it's going through it, just basically read the clock. Does this need to be changed? Read the clock. Does this need to be changed? And if it does, then do the steps to do it. And this runs at 60 megahertz, which compared to modern computers is not fast. But for what we're doing here, it's just more than enough. And one of the coolest things I've ever seen, and I want to do it, back when I was in college at Starfest, I saw this guy that built this big model, lit it up, and he had sliding doors on it that you could open and close, flip a switch, closing. Yeah. So it's like, we've got, one of the things you can play with on the Arduino is servos. I mean, this isn't a great servo, but you can go to Copart and buy really decent hobby grade servos that make stuff like that happen. You can hook up stepper motors. That's all it is. What runs your hard drives. You can have big rheostats, big knobs. You can put, push buttons in it. One of the problems with those is that they're not manufactured to really great standards, so it's like you got to figure out a way to cut out the ripple, because it's like if you have a real precise timing, you don't want that ripple. You want to read the button and execute. And that's my current problem, because it's like with all the timers, I don't want to debounce the buttons in the code, because I don't want to spend any time more than I have to reading the code. So now I have to figure out how to do that with hardware.
This doesn't work with fiber optics.
You know what? Yes, it will, because all a fiber optic is just a piece of plastic that transmits light. So, you have your fibers set up, and your LEDs are driving those fibers.
I got a line set up so that I sand off the end of the LED, polish it, and then I'll stick it into the end of a piece of shrink, plastic shrink or wire, and then I'll take the LEDs and I'll put those in, shrink all of it together, and as long as that LED and the light is not really in contact so much as close.
Yeah, you'll transmit the light. It'll work.
You put multiple light sources on.
Oh yeah. Yeah. You can have a red LED, a green LED, a blue LED, a yellow LED, orange LEDs, and you just set them up, and you've got fibers coming off of each one, and you can send them. You can light a cockpit that way. With the fibers go to different spots, and if you want it to fade, then you program it so that it's like I'm going to have these. I'm going to have the cockpit change what it looks like. While
Lights off.
yeah. And it's really, it's not hard to program. It's not hard to learn how to do this. There are a lot of resources online to do it for building your Are you guys on Facebook?
Yes.
Are you guys part of the 350th Scale Enterprise Group?
Yeah.
Join the 350th Scale Enterprise. Because there's a lot of people there that will have a lot of ideas, and it's like one of the big things that they'll push the tenant controls and the big easy problems. But if you want to roll your own, you ask questions. And I'm there, and I can sit down and say, hey, well, here's the code snippet that I'm working on. See if it works for you. And, as far as learning, I cannot learn this stuff without books. I love my books. It's like I picked up these two when I bought my first experiment kit. They'll give you all kinds of fun things, and you can do it. No, I got these at Micro. Well, I got this one from Amazon. I got these from Micro Center. And hopefully, once Micro Center finishes getting their remodel done, everything will settle out. But yeah, I bought almost all of this at Micro Center. I have been buying LEDs on Amazon and eBay though. I've got like 200 cool white LEDs at the moment.
From China,
100,
Hong Kong, it's like
100 warm white LEDs. I've got RGB LEDs. Because you can't find the blue amber ones anymore. They don't make them. So you got to use the RGB to get your amber light the way you want it to reflect it.
You might also try
yeah, I mean, using a warm white LED, I think it would work a lot better than a cool white, because the cool white's really blue. I have.
It's like a vanilla It's This one is, regular phones and things. So I don't know why I don't do it. It went right.
Another good place to buy LEDs from is HTA Model Works.
Is that online?
And I've been buying a lot of stuff from him because he's a little bit more expensive, but he's got odd sizes. So that's a cool light. There's
And you can get them, I got some LEDs that are actually square, and they have a thin ribbon that comes out the ends of them, and sticky on.
Yeah.
You can stick them up inside, and the light should go side. It's already got resistor in it.
Yeah, and with that one,
Yes.
and with that, it's like when you're lighting your models, definitely paint them a decent flat black, and then flat white on top of that, and then the white. There's a I've got so many LEDs right now. I've got all kinds of different sizes of LEDs for various spots. I've got 1.8 millimeters for the navs, and I've got SMDs for the spotlights in the cells and around the bridge and the planetary sensor. It's a sickness. It's a sickness.
I don't want to be clear.
Any questions at this point? You really can do almost anything. And I would recommend just get an experimenter's kit, get a parts pack, and start playing.
Get those at Micro Center.
Yep. Yeah, I got mine at Micro Center.
Where is this Micro Center?
It is nerd heaven. It's down at Tamarack and Quincy. So you get off of 225 at the Tamarack exit, and you go north on Tamarack, and you take a left and you get clear of the highway. And you're there.
Right there on the corner of the Mexican restaurant that just behind it.
Like I said, it's nerd heaven. I bought parts from my last people and built it.
The only thing I really like about them is that sometimes you can't remember.
Yeah.
When they're looking for the shelves, sometimes just drives me nuts. When you ask for help, they don't.
Yeah. I mean, before they started their remodel, it was a lot easier to find things. And it's like this. And they got a lot of stuff, but it's like, bins and eggs, and you got to dig. And,
Digging. That's why I do love it.
yeah.
I have a picture that says buying.
Yeah. Yeah, HCA Model Works is a good resource for lighting parts. eBay, Amazon.
I get most of mine from the same company. Right. Stuff like that. I give it within 5, 6 days.
Oh yeah. Yeah. Yeah, right now off of Amazon, you can get LEDs for $6. Like, when the refit first came out, it would be, you're looking at hundreds of dollars to buy all the LEDs in your building. Not anymore. Any other questions?
Well, I've got Russian battleship over there's got the last case.
Yes.
And then I have the Churchill class there. And I have an Abrams 116. And I have a Japanese Italian seaplane. I'm retired. Oh yeah, I don't. I belong to a club, and there's some guys that they just do airplane. They just do I keep it interesting.
Yeah, yeah.
Always find a
Oh yeah, yeah. Every different model builder can teach you something. I mean, that's just the people that sit down and say, well, armor only. All I want to do is armor. Airplane guys, they don't know nothing. On the sci-fi guys, But there's something you can learn from everybody. Any other questions?
No.
This really is. It's
Go
not
get me
bad.
one of those. How much did you pay for that?
That one I think I paid about $17 for it. And I mean I didn't spend more than $40 for the initial kit because with this one it came with the Arduino, the breadboard, and jumpers. And a couple some LEDs and some resistors. So it's enough to get started to play around.
But the program itself is not.
Well, this is the official Arduino development environment. It's free. It's all shareware. So it's all, or no, it's not even shareware. It's freeware. It's it's like all they ask is if you use one of their sketches, give them credit, and the community is great because everybody wants to help everybody else. And we want to see cool stuff done. And if you want to get more into the realm of physical computing, there really is a lot of cool things you can do with it.
And that's via their website.
No, that's via their website. And Adafruit has got some really good tutorials. SparkFun's got good tutorials. There's a couple of boards on Facebook for it.
YouTube somewhere, I'm sure. That's where I get most of my stuff.
Yeah.
There's a lot of people out there that have Facebook.
Yeah, but it's like a lot of it is wading through the bad stuff. Because there are people out there that don't know what they're talking about. Like, I apologize, this wasn't the best presentation because I got asked, last minute to put it together. But it's like at least I know what I'm talking about. I'm not presenting it well, but I know what I'm telling you.
Well, that's great.
Yeah, I picked that up because it's like I realized early on that I needed transistors, and even though I'm an Air Force veteran and I went through a tech school that tried desperately to teach me about transistors, that's black magic. I do not understand how transistors work. But I know what it does.
And it gives you 15 types of them.
Yeah, that's the big thing too, because like, when I was saying the Arduino's only rated for so much current, same thing with the transistors. If you run too much current through it, you're going to blow it. So that's probably the biggest challenge in electronics is sizing, making sure you got enough power to run everything, sizing it up properly.
Speaking of that, you come to the show and nothing to get, and you need a good portable power supply. What would be the best one you would recommend?
There's a lot of different ways you can do it. You can do it with batteries.
On the generator, just bring that in and crank it
Well,
up.
and honestly too, it's you're not going to be. You can size things down to about between 9. You can run it off of 9 volts,
Which is what I use.
or design it for 12 volts. You don't really need a lot of power. I can put the batteries. I've actually got some. Oh, there they are. This is a project I'm working on. I'm lighting the cockpit for a 48 scale Eagle transporter, and I'm just going to use button batteries to do it because it's 2 lights.
Yeah.
Put 2 of these together, 6 volts, easy peasy. Yeah, ask me when it's done.
Okay.
But yeah, it's like, theoretically, it's like, 2 LEDs, 2 resistors, 2 button batteries, and I'll have a nice warm white glow in my cabin.
He's trying to avoid, right now, his battery is integral to the bar.
Okay.
So to change it out, make sure he's got enough juice to run the whole show, he's having to take off the cover and then put
Yeah.
it in and so on and so forth. But we have seen people here with stuff on the ceiling. It's like a bunch of batteries together.
Yeah. I mean, because you can build up your battery pack. I mean, if you can find the space for it, D cells, they're not popular, but that's going to give you a ton of milliamp hours.
All I'm saying is something more. Right now, I've got a model of 15 to run off the wall output, transfer it down to like 9 volts.
Yeah.
So I'd like to keep that if possible, and then just plug it into something and then I can just run the
Yeah. Yeah, I've got a K7 space station that I run it the same way, where it's like it's now set up for running on 4.5 volts and a wall adapter. But, it's like 3 AAAs, plug it in, not a problem.
If I have to get rid of the adapter.
Well, no, I'm setting up the battery box so it plugs into the wall wall. So it's like, depending on how I power it, that's where the power's coming in.
Okay.
And you can set it up like you put your batteries in the base, and then it runs up to the power connector from there. And then you could put in you could use RC car batteries, you could use C cells. I mean, RC car battery packs are pretty much C cell size, but they have a much higher milliamp hour capacity, and you can build a big brick to size it up to the voltage you need. And it's gonna run for a while, and especially because LEDs, they're not drawing a whole lot of current, so it's gonna last a long time.
I'm counting on that.
Well, I think you should.
Oh,
Not a
thank you,
problem.
sir.
Yeah, the big thing to worry about on LEDs though is running them in series, because then it's like the Christmas tree lights. You lose one, you've lost them all. You've lost everything from that point on. And honestly, from an electronic standpoint, it makes the math hard. You're trying to figure out how much current the whole build is drawing, because then you're not just using Ohm's law. You're not having to use Kirchhoff's law to figure out the resistance of each leg and adding it all up. And then you got the resistance of the whole circuit, and that's how much current you need inside the power supply for it. Whereas if everything in parallel, this current, and I'm done.
Add something else. Thank you.
You're welcome. Enjoy the rest of the show. All right, go ahead and hit the X on the top. You want to give me a hand cleaning it up?
Oh, I gotta press OK.